Have you ever stepped on a Lego and felt the burning, suffering feeling knowing that this is your last breath before it overcomes you? If you answered yes, then you've experienced pain.
But why does our body let us go through pain? Pain is a way your body notifies you of a potential harmful situation. When your nerves sense that your body is being damaged, it sends signals from pain receptors in the form of chemicals through the cell body to the axons where the myelin sheath allows the neural impulses to be sent at a faster rate. From the axon, the message is then transferred to the axon terminals and then to the nearest neurons, dendrites, until the message is sent to the spinal cord and directly to the brain. The cerebral cortex of the brain processes the message, and the brain sends back the pain message to the somatosensory cortex that is responsible for physical sensations, the frontal cortex that allows you to think and register pain, the limbic system for emotional response, and lastly back to the origin of pain.
This all ends with the body's final result of feeling the pain with an emotional response and mental recognition. These nerves, called nociceptors, span all throughout your body, from your spine to your toes to even your teeth. Nociceptors are like other nerve cells, except they're specialized to warn the brain of damage being done to your body. The threshold of nociceptors can be lowered by the presence of certain chemicals. Over-the-counter painkillers are what help re-raise this threshold back into place.
When cells in your body get damaged, they produce a large amount of enzymes called cyclooxygenase 1, COX-1, and cyclooxygenase 2, COX-2, which produce chemicals called prostaglandins that send pain signals to the brain. The damaged cells also release arachidonic acids, which is then broken down and converted by COX-1 and COX-2 to produce prostaglandins, lipid mediators that send pain signals to the brain.
COX-1 and COX-2 also cause inflammation in the damaged area in order to cushion and protect the damaged cells. Aspirin and ibuprofen are two commonly used painkillers that can inhibit the pain signals that COX-1 and COX-2 send. Aspirin is able to do this by entering the active site of COX-1 and COX-2 and then breaking off, leaving a small part of itself within the active site which stops COX-1 and COX-2 from being able to bind to arachidonic acid and release prostaglandins and pain signals, therefore eliminating the pain.
Ibuprofen works in a similar way.
Although, instead of breaking off and leaving a small part of the ibuprofen within the active site to block it, the whole ibuprofen remains together and blocks the active site. This makes aspirin have a longer lasting effect than ibuprofen, having a lesser chance of falling off the cyclooxygenase considering its small size. But aspirin takes longer to show noticeable effects after consumption.
So aspirin or ibuprofen, that's a decision for you and your doctor to make. But now you know how these vital painkillers work within your body to relieve your pain.